Hello and welcome everybody to Quadratic Functions and Equations Lesson 4. So today we're looking at finding equations and intercepts from the vertex and having a point. So taking these two pieces of information, building our equation, and then from there finding our intercepts. So it actually tells you, and we're doing this from our standard form that we've been dealing with. Y is equal to a multiplied by x minus p squared plus q. And it actually is really awesome because it outlines the process right here really nicely. So step one is replace P and Q with the coordinates of the vertex. And then you're going to replace X and Y with the coordinates of the point you're looking for. And we're going to solve for A. That's the only one that we can't really, like that value, we can't just pull off of the graph. So we're going to solve for it. And then we'll replace the values of A, P, and Q in the equation to build our equation. So if you're ever unsure, just do these steps. So let's have a look at what they're talking about here. So it says, the graph of a quadratic function has vertex -2, 8, and passes through the point -1, 7. Find the equation of the function in standard form. Well, we know that our equation, we know the p-value. Oh, my pen's not working. Oh, good. Oh, there we go. A little bit of a lag, that's all. Let's see if it'll erase that. Oh, perfect. Here we go. So we know the p-value and the q-value. That comes from our vertex, right? We know that our vertex is pq. So we can plug those in. So our equation is y. Actually, let's see if I can turn this into a vertical surface or a horizontal surface because it's easier to write on. Oh, hey, buddy. How's it going? You having fun outside? I'm making a video right now. So we are going to create our equation. We don't know a yet. X minus p. So when we go minus, sorry, my dog is playing with toys. If we go minus -2, see, this is why I don't do it. My palm hits every time. Okay, let's try. Y is equal to ax minus, so our p-value is -2 squared plus q, which is 8. So you can rewrite this when subtract a negative part, because we know that when we subtract a negative, it is just x plus 2 squared plus 8. If you want to skip that step because you understand that the negative becomes a positive, that's great. I just wanted to show that and how we got there. So the trick now is this equation would be done if we knew our a value. But in this case, we don't know the a value. So what we need to do is find any point on the graph. Luckily, they give us one, and plug that into the x and y value, because we know that point is x and y. So we can plug that into y and x, and we can solve for a. So my y is 7, so now I have 7 is equal to a. X is -1 plus 2 plus 8. So -1 plus 2 is +1. That's squared. +1 squared is just 1. So if I take that up here, basically what I end up with is 7. 1 times a is just a. So we have 7 is equal to a plus 8. I can subtract 8 from both sides, and I have a is equal to -1. Now that I know the a value, I can go back to my original equation that I had right here, and I can just rewrite it with that a value. So now I'm going to say y is equal to negative, and I'm not going to put the 1. We don't have to put the 1. We know it's there. Negative x plus 2 squared plus 8. And that's our equation. It's important that we find the a value. Now what we're going to do is rewrite the equation in general form. So I'm just going to scroll down a little bit, if it'll let me. My computer's being super laggy, and I apologize. So we know that we have, actually let's go down. There we go. We know that we have y is equal to negative x plus 2 squared plus 8. And we want to write it in ax squared plus bx plus c form. So we want to expand that. So we know it's going to be negative, and it's going to be x plus 2 times x plus 2, because it's squared, plus 8. We can do our FOILing there. So if we FOIL those two binomials, we're going to get negative x squared plus 4x plus 4, and we still have that plus 8. And then you can factor that through, that negative 1 through. That negative 1 is going to apply to all of them. So now we have negative x squared minus 4x minus 4 plus 8. And we can combine our like terms here. So our equation becomes negative x squared minus 4x plus 4. So these two are the same equations, just written in different forms. Fantastic. Hopefully that made sense. We're going to scroll past that, and we're going to look at finding intercepts from the standard form. So now that you've built your equation, you can actually find the intercepts algebraically. You can also graph them, but you're going to have to know how to do both, and this one's a little bit trickier. So the trick is we know that, there we go. Oh my gosh, what's going on? When we're solving for the x-intercept, we set y is equal to 0, and we solve for x. So if we do that with our equation, we know we'll have 0 is equal to 3x minus 1 squared minus 9. And now we're going to do some algebra to solve for x. So I'm going to add 9 to both sides, and we get 9 is equal to 3x minus 1 squared. And then I'm going to divide by 3 on both sides. And now I have 3. Oh, that's green. 3 is equal to x minus 1 squared. I need to deal with that squared exponent up here so I can square root both sides. And when I do that, my left side is still square root 3. We're going to leave it as square root 3 because if we don't, it becomes an irrational number. So a number that just goes on forever. So it's more exact if we leave it as square root of 3. And let's go back. And we have now x minus 1. So what we can do is, so we got to be careful because when we take that square root, it's actually going to be plus or minus. We're not sure if it's going to be negative or positive, and that's the same. What I mean by like the reason that happens is because if we take the square root of 9, we know that it's 3, but it also could be negative 3. So we actually have to say the square root of 9 is plus or minus 3, because 3 times 3 is 9, and negative 3 times negative 3 is also positive 9. So in this case, we have to say, well, we don't know if it's going to be plus or minus. So it's going to be plus or minus root 3 for right now. And then last step, we're going to add 1 to both sides. So now we have x is equal to plus or minus root 3 plus 1. And you can flip-flop those terms. It'll make it look a little bit nicer. So we can say x is equal to 1 plus or minus root 3. And that makes sense. I know it seems weird, but it's a parabola. We should have two x-intercepts. So one of them, so this splits. One x-intercept is going to be 1 plus root 3, and the other one's going to be 1 minus root 3. And that's why we have plus or minus there. And that's the way we're going to leave it for our x-intercepts. We could get decimal numbers, but they are going to go on forever. And then I don't have a lot of room, but we can do the y-intercept as well. So we know in the y-intercept, we're going to set x is equal to 0. So when I do that, I'm going to say y is equal to 3, 0 minus 1 squared minus 9. And we just do some algebra here. So 0 minus 1 is negative 1. Negative 1 squared is going to be 1. So now I have 3 times 1 minus 9. And then 3 times 1 is 3 minus 9. So I get y is equal to negative 6. And that's my y-intercept. So the y-intercept's a little bit nicer. The x-intercept gets a little bit weird. So this step here, whenever you are in standard form and you have this binomial squared, that step will always happen, where you have to take that square root and then do the plus or minus. The more you do it, the more you'll get used to it. All right, so now we're going to put it all together. So we have a parabola here, and it says find the equation of the function in standard form. So they give us a vertex here, negative 1 and 2, and they give us the xy point, negative 3, 1. So we can start our equation. We know it's going to be a x minus p squared plus q, and the p and the q are going to be our vertex. So we can say y is equal to a, and then we should have x, that negative 1 becomes plus 1 squared, and q is plus 2. And now to solve for a, we have to plug in that second point that we know in for x and y. So we can plug in the point negative 3, 1, and our equation becomes 1 is equal to a negative 3 plus 1 squared plus 2. And we can solve for a. So in the brackets, I have negative 3 plus 1 is negative 2. Negative 2 squared becomes positive 4. Now I can do some algebra to solve for a. I'm going to subtract 2 to both sides. I'm left with negative 1 is equal to 4a. And I can divide 4 out of both sides. Cancels out on this side, and I'm left with a is equal to negative 1 over 4. Now that I know that, I can plug this back into the original equation where the a is. So you can say y is equal to negative 1/4 multiplied by x plus 1 squared plus 2. And that's our equation. And that makes sense that it's a negative because it is a downward facing parabola. Oh, that just disappeared. Which is an unhappy parabola. So it says here, find algebraically, which means using algebra, the x-intercepts and the y-intercepts of the graph. Answer both as exact values. So, and to the nearest hundredth. So we're going to actually take these to the decimal now. So we know for the x-intercept, we're going to set y to 0, and we're going to solve. So we have 0 is equal to negative 1/4 x plus 1 squared plus 2. So we can subtract 2 on both sides, and then we're left with negative 2 is equal to negative 1/4 x plus 1 squared. And then we can multiply both sides by negative 4 multiplied by negative 4, and that's going to get rid of this negative here. And when we multiply this side by negative 4, we are going to get positive 8 is equal to x plus 1 squared. This is that weird part that people are going to really not like, but all you're doing is taking the square root of both sides to get rid of that exponent 2. And when you do that, this needs to be a plus or a minus. So now we are going to get plus or minus root 8 is equal to x plus 1. So we're going to subtract 1 to both sides, and we get x is equal to we could do negative 1 plus or minus root 8. Or if you remember your radicals, x is equal to negative 1 plus or minus root 4 root 2. and then x is equal to negative 1 plus or minus 2 root 2. So to actually solve the values of those, you're going to have to do, running out of room already. So one of them is going to be x is equal to negative 1 minus 2 root 2. And the other one's going to be x is equal to negative 1 plus 2 root 2. And if you do those on your calculator, you're going to get negative 3.83 and 1.83 as your x-intercepts. And again, I left myself no room to do the y-intercept, so let's see if we can sneak that in. So if we're doing the y-intercept, we're setting x is equal to 0, and we're going to solve. So we have y is equal to negative 1/4. 0 plus 1 is just 1 squared plus 2. 1 squared is 1 multiplied by 1/4 becomes negative 1/4 plus 2. And when you change 2 into a fraction over 4, we know that 2 is actually 8 over 4. 8 over 4. And negative 1/4 plus 8 over 4 is going to be 7 over 4. That's your y-intercept. That's pretty much it. We're not going to do so much domain and range stuff. We just don't have a lot of time, and I really want you to focus on the algebra and finding these intercepts. So that's it. Thanks for watching. Don't forget to like and subscribe. Lesson 5 video is probably going to be up on maybe Saturday, but most likely Sunday morning. I've got a ton of things I'm doing, so don't freak out. It'll be up there, I promise. Have a good weekend.